Now we're going to move on to the last two laws of indices. So suppose if n is a positive integer, note that for now the powers that we've been learning has always been positive. Okay, afterwards you're going to encounter negative, but that's in the next few chapters. Now, if you have different bases here, a and b with power n, what you have is a to the power of n, b to the power of n. So let's explain with a concrete number. Suppose you have 2 to the power 2 times 3 to the power of 4. They also take. Okay, so what you have is actually 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3. Right, so 2 and 3 are different base. They are different bases, and you have multiplied, they multiply by themselves for 4 times. So this is what you get to the power of 4. So if you rearrange, it's actually just 2 times 2 times 2 times 3 times 3 times 3 times 3, right? Because remember, for multiplication, the order doesn't matter. So we can rearrange them. So in the end, what you have is how many 2's? There are 2 to the power of 4 and 3 to the power of 4. So this is how you get, okay, to a to the power of n, b to the power of n. Of course, here we omit the multiplication sign. Okay, so for law 5, suppose you have 2 over 3 to the power of 4. Okay, again, it's the same thing. Your power applies for both the numerator and denominator. Okay, so you can either see it like that, or you see it as 2/3 multiplied by themselves 4 times. Okay, 2/3 multiplied by itself 4 times. So what you have is okay, 3 times 3. So you will still get 2 to the power of 4 over 3 to the power of 4. Okay, but please take note here that b is not equal to 0. So your denominator can never be 0.